So yesterday I gave a sum, right? Got the answer? Huh? Solved it. So solved it or not? Huh? Now put the answer in the rare madhuda. Okay, how? Okay, wait, I'll solve it. I'll not write the question. See. Mole fraction and pressure. Actually, see, the medium, which is very, very important. Either it's solid or liquid or gas, like the medium is important. If you're taking liquid and liquid, in a closed, if there is any boundary in the sense, so what happens, the liquid will absorb the temperature from the surrounding and it will be converted into vapor. So once if it converting into vapor in the sense, it will hit the boundary and again it will just getting into the solution, right? So what happens depends upon the medium. There is everything, there is a connectivity between the mole fraction and the pressure. Mole fraction is nothing but solubility. So with that only your cool drinks is getting cracked. Correct. With the pressure, what happens? The carbon dioxide is getting soluble, right? Solubility. Clear? Huh? Pressure is directly proportional to mole fraction. If pressure increases, mole fractions will be increasing. Okay. So if you're increasing high pressure, so what happens? The carbon dioxide gas solubility is getting increased in the cool drinks. That's it. Yes. So in yesterday's questions, yaar mein solve kar liya. At least try. No. Enna panninga veetukku poi? Okay. So actually, I'll not write the question. So first given data. See, they have given KH for CO2 means Henry constant. Henry law constant. Okay, wow. So KH is 5/3 kilobar. Correct? Yes or no? And next one is determine the concentration of the CO2 in rainwater if the CO2 is if the CO2 is 1% by mass. See, they have given the mass as 1%. Okay. So now, what is the thing which is having in our hand is Henry law constant. We know partial pressure is equal to Henry law constant into mole fraction. Yes. So we are having only this thing. Now we want to identify the pressure. If we are identifying the pressure, then only we can calculate the concentration. Concentration in the sense that is nothing but the mole fraction. Correct? That is the concentration terms. Can you understand the thing? Okay, they will not directly give you to identify mole fraction. Okay, they will say what is the composition, what is the quantity, what is the concentration. In that terms, you have to identify. Okay, so they are asking the mole fraction. Now, how to identify this pressure? Okay, so now come to the think in this way. If mass they have been given, see, determine the concentration of CO2 in rainwater if carbon dioxide is 1% by mass. So if total mass is 100%, okay, say for example, if total mass is 100% means, okay, CO2 is having a mass of 1%. You got, okay, now only you got. So now cross multiply. Okay, so which means 1 into 100% into CO2, which is equal to CO2 is equal to, just keep it as X, okay, which is nothing but 1/100. Okay, so what is 1/100? 0.01. Okay, so here it is nothing but a percentage. Correct? This is percentage, right? But we need in terms of pressure. What are all the parameters to mole fraction? That is okay. So you need to convert it into pressure terms, right? So what happened into, see, you can write directly this percentage into grams. Conventional method, in conventional methods, what happened? We will be dividing by 100 everything. It's negligible. Anyway, in the answer, what happens? 0.000, that kind of conversions will be there. So you just don't go for that thing. Directly you can write it as 0.01 gram because they have openly said it's a mass. Correct? So mass is equal to, see, if solution is there. If your solution is 100% means your solute is 80%. Okay. Your solvent is 20%. Okay. Take it in this form, which means 100%. So in the 100%, you can also write in grams, right? Okay. So some persons, or if you think you like literally want the conventional method, means you can directly go for it. Divided by 100, you can go for it. Immediate answer is same only. Okay. So we need to convert it right now. Mass of CO2 is this much means we need to convert into pressure. So into pressure means 0.01 gram. And look at what they have given here. They have given in kilobar. So we can convert it into bar, which is equal to nothing but 1 bar. So 0.01 bar. Convert it in this form. So now take this and substitute. Multiplying by what? See, we need to convert this. We need to convert this, right? Correct? We need to convert. Okay, 0.01 gram. So actually, this mass is nothing but See, actually here it is 1 gram divided by 100 gram. Keep it, and here just get the grams cancelled. Okay. So now it is in this way. Now into 1 bar. Now you got the point bar. Okay. Percentage here. In this here itself, I have just got converted into grams. Clear? Okay. So what happened in the sense, I have striked to this grams and finally I have got 0.01 is your mass. Now I'm converting it. Why I'm converting it to 1 bar in the sense, what are all the necessary components? Pressure, our Henry law constant and our mole fraction. Okay. So now we are having our Henry law constant. This is our pressure. We have to convert it into pressure. Like suppose, we will be no, there will be no problem arriving. Suppose they are asking to convert into Pascal means, if this 5 points, see, this 5 by 3 instead of kilobar, if they have written in Pascal means what will you do? Our 10 power 5 means 1 into 1.013 into 10 power 5, right? So that's why you need to multiply into 1 bar. Because another one more term. Here you can see 5 by 3. Always these kinds of units should be similar in your question. Okay, so whatever there, you have to take it here also. So here we have got this 0.01 bar, and further we are just going with our formula. Partial pressure is equal to KH into X, and X is equal to P divided by KH. So what is our partial? What is our pressure? 0.01. Okay, bar. What is our KH? 5 by 3 into, they have given kilobar, correct? So 10 to the power 3 into, so which means this bar and bar will be getting cancelled, and just take this 3 on the upper side, 0.03 divided 6 into 10 to the power minus 6. This is your answer. Clear with this one? Don't wait. That is in the atmosphere. Yes. You got this one? Any doubt with this one? Wait, you do next. Something will be getting an idea. Wait. See, always. Okay, wow. So next question, do this one. Henry. See, there is more than like 30 to 40 problems this year. If you have any doubt, just ask me, okay? Physical chemistry is full of problems only. Henry law constant, KH for oxygen dissolved in water is 4.34 into 10 to the power 4 atmosphere at 25 degrees Celsius. The partial pressure of oxygen in air 0.4 atmosphere. Calculate the concentration. Again, here also they're asking only about the mole fraction. Okay. Mole fraction. Let's suppose, look at here. Concentration moles per liter, which means moles per liter means it is molarity. Okay, you have to find your mole fraction. And in that mole fraction, you will be getting your number of moles. Correct? For here, oxygen. So, number of moles of oxygen is number of moles of solid divided by 1 liter of the solution. In water at 25 degrees Celsius. Okay. So now, do this problem. First one, they have given Henry law constant to touch. Okay. So, Henry law constant. Partial pressure. Again, see, Henry law is nothing but gas in liquid, man. So oxygen in liquid. So 1 liter. Okay. You can understand thing. Henry law only speaks about gas in liquid. Okay. Most of the Henry law's question will be with your gas and your liquid. And do remember, if they have given like in most of the cases, they'll be giving only 1 liter. Sometimes they will mention it as 500 liters means at that time, sorry, 500 milliliters means at that time what happened? Already yesterday I have given no. For 1 liter of water, okay, for 1 kilogram of water, fixed number of moles is 55.5. Okay, if they have given 500 milliliter means you have to divide it by, carry over this problem. So Henry law constant is in water is 4.34 into 10 to the power 4 atmosphere. Okay. Next one, partial pressure also they have given. Partial pressure is equal to, partial pressure of oxygen is equal to 0.4 atmosphere. Clear with this one? And now, so next one is partial pressure is equal to kH into mole fraction. So X is equal to, that is mole fraction of your oxygen is equal to partial pressure divided by your Henry law constant. 0.4 atmosphere divided by Henry law constant is 4.34 into 10 to the power 4 atmosphere. Anyone done this thing? I have written only the answer here. I'll go. CO2, O2. Cross check. 0.4 divided by 4.34. 0.0921 into 10 to the power minus 4. You're rounding off the figure. 9.21 into 10 to the power minus 6. So now you got the mole fraction of X to O2. Now you have to calculate number of moles. So mole fraction of O2 is equal to number of moles of oxygen divided by number of moles of oxygen plus number of moles of water. Solute divided by solute plus solvent. Everyone can understand this. Only water, man. Always in most, see, 99% of the problems, you don't need to put the number of moles of gas in water. The solubility is negligible. Okay. Unless when they are openly, they have been disclosed means you can put. I'm having that sort of problem also. Okay. So now, number of moles of oxygen is equal to, sorry, mole fraction of oxygen is equal to number of moles of oxygen divided by number of moles of oxygen plus number of moles of water. Okay, so which means we don't know number of moles of oxygen. This value is negligible. Number of moles of water is equal to 55.5. Directly, you can just write that thing. And here it is 9.21 into 10 to the power minus 6. Clear? So it will be, directly you need to multiply. 9.21 into 55.5, which means number of moles of oxygen is equal to 511.15 into 10 to the power minus 6. So, how, got anyone got this answer? This is answer. Again, bring it here. So, which means 5.11 into 10 to the power minus 4. Clear? Got this one now? Yeah, answer about copy reading. Got this answer? Got now finally you have to calculate. See, they have given in the question the concentration moles per liter, which means you need to calculate your molarity. Molality means it's kg, that is mass of the solvent in kilogram. Here they have been given it. It's very simple. Molarity. Molarity. I'm saying molality means it is mass of solvent in kilogram. Okay. So molarity, which is nothing but number of moles of solute in 1 liter of solution. Okay. So the answer is actually similar answer. Divided by 1 liter na adega. So moles per liter. Clear? Shall we go to another level, little bit difficult problem? If you have any doubt, please ask. I'm having so much of problem. Wait, everyone got number of moles of solute in 1 liter of solution. Okay. Shall trying another problem? Do this one. Next class I'll bring PPT. Yeah, question ADA part time. For a solution of acetone in chloroform, CHCl3 okay, wow. Henry law constant is 150 torr. At temperature 300 Kelvin. Calculate the vapor pressure of acetone when its mole fraction 0.12. Now, wait. Another one more subdivision is also present here. Assume that Henry law is applicable over sufficient range of composition at which Henry law pressure of chloroform is equal to Henry law pressure of acetone at 300 Kelvin. So they have given the Henry law for chloroform is this 175 torr. See, the question now is the problem is very much easy. Assume that Henry law is applicable over sufficient range of composition at which Henry law pressure of chloroform is equal to Henry law pressure of acetone. Okay, at 300 Kelvin temperature. And see here they have disclosed there is a pH for acetone, that is Henry law constant of question easier பண்ணிடலாம். See, very much easy. Take this one. They have given your mole fraction. Huh? What you need to convert into? Both are given in torr, right? Don't need to convert it in. Okay. So here they have given your x. This is your KH. So multiply panna partial pressure. Continue. What happened? 1.8. 150 into 0.8. 80. Next one, read the question carefully and try to answer the next one. கண்டுபிடிச்சிட்டீங்களா? What is the first one? 80. What does the second one says? See, it will openly entry law pressure of chloroform is equal to entry law pressure of acetone. So here definitely you have got the pressure of the acetone, right? Substitute here. What is composition? Composition. Composition means you have to find the mole fraction. Mole fraction, right? See, why they have the wait a minute. Why they have set this line? Assume that entry law is applicable over a sufficient range of composition. Just this one. Entry law is applicable over a sufficient range of composition. Means to any spectrum at any composition is applicable. Okay, so which means composition in the sense there is a kind of inert gases. There will be a kind of high solubility gases and low solubility gases. It's not talking about those gases. It's saying about the liquids. For liquids at any composition is soluble. So which means for liquids if it is any composition is soluble, it can be this is also liquid, this is also liquid. So both is getting the equal pressure. Upper end here we have our pressure. We have our pressure from the pressure in the last question we have got the pressure of acetone that is equal to the pressure of chloroform. You can take the similar value, right? Yes or no? And the second one is they have given the entry law constant as 175 torr. You can substitute and say the answer, right? Wait, I'll solve this thing. Expert chloroform. See, what composition in there? You need to compose for chloroform. See, initially what you found here for acetone, right? So here you need to count for chloroform, right? Henry law of chloroform they have given, right? So partial pressure is equal to KH into X. So here the partial pressure of acetone is 18, correct? 18. KH they have given 175 torr. So there also you will be having 18 torr, which is into X. So X is equal to 18 torr divided by 175 torr. So torr gets cancelled. 18 divided by 175. So which means 0.102. Say 2 or 3, anything. Okay, fine. What? Understood? Huh? Chloroform. Yes. No, they won't give like that. This is a question. Composition, concentration, quantity, or they will give any some other molarity, solubility, whatever it might be, you need to only find the mole fraction. That's why while teaching mole fraction, I said it has a connection with Henry law. Clear? They won't give us openly, just find the mole fraction. KH, they will be openly, they will disclose. This is the KH. Pressure also, sometimes they will disclose, sometimes indirectly you have to substitute with the units. 1 bar, 1 atmosphere, 1 Pascal. Vapor, no, that is what you're going to see in your Rawls law. What? Vapor pressure and vapor pressure of acetone. So here, see, in this case, with gas and liquid, you don't need that kind of differences. Okay, up to your syllabus. If you want to go to higher level, means it will be quite complicated. Vapor pressure and partial pressure, here you just take it as a similar factor, because the gas, once it gets high pressure, it will be getting soluble. But once if you're taking liquid and liquid, at that time, it will be having a kind of certain differences. At that time, I'll teach you. Clear? Yes. Vapor pressure will be 2 times molarity. Yeah. Where you studied that thing? Huh? What is vapor pressure? What is vapor pressure, first of all? Hey, no, wait. Water bottle. Huh? This is a water bottle. The liquid is present here. Correct? So first my question is, this is a liquid. When you're just keeping in a room temperature, what this liquid will do? It will absorb the energy, and this liquid will try to escape as a vapor. Yes or no? It escape as a vapor. So this vapor, it is in a confined environment. Sorry, it is in a confined boundary. Correct? So what happened? It will hit the surface. It will hit the walls of this water bottle. That is a vapor pressure. No, but to be precise, to be concise, okay? That's what I'm saying. So this is vapor pressure. Now, okay, I'll deal this thing. This is what the Raoult's law will tell about. First, we can solve the problem, and then we can go to Raoult's law. Okay. Partial pressure is, see, if I'm taking, I'll say in this, there is another problems we can solve. Huh? Okay, do this problem. Do you find difficulty in learning this chapter? Because comparatively in organic, you are more reactive than here. KH for carbon dioxide in water is 1.67 into 10 to the power 8 Pascal at 298 Kelvin. Calculate the quantity of carbon dioxide in 500 milliliter soda water, which is packed under 2.5 atmosphere. Okay. See, look at the question. One of the unit of pressure is Pascal, another unit of pressure is atmosphere. So convert this atmosphere into Pascal. What will you do? 1.013 into 10 to the power 5. So just convert it and say in Pascal, in atmosphere, into 1.013 into 10 to the power 5. Your values will be getting altered. I have done in most of the problems what happened. Oh, plus or minus 3 variations just coming. Is it accepted in your exam point of view? Is it accepted? Plus or minus 3? Huh? What? I don't know. See, in the first problem, no, for 7.16, no, I got 7. No, I got 6.8 or something else. Then I have approximately, I have precisely calculated with the values. Then I got it. I don't know. In competitive level, they will give the options. So we can go through the options. In this kind of thing, we have to calculate. Calculated. See, 1 atmosphere is equal to 1.013 into 10 to the power 5. So here it is 2.5 atmosphere, which is equal to 1.013 into 10 to the 5. So just divide it. Two 2.5 divided by, okay, we can directly substitute in the right. So next one is, what are all the things we know? Partial pressure is equal to KH into our mole fraction. So partial pressure, we can take that thing. What is the Henry law constant? Henry law constant is 1.67 into 10 to the power in 8 into 10 to the power 8. 2.5 atmosphere. Okay. So, equal to 2.5 into 1 into 10 to the power 5. So here X is your carbon dioxide. So mole fraction of carbon dioxide is equal to 1.67 into 10 to the power 8 Pascal divided by 2.5 into 10 5 Pascal. Sorry. Wait. Into 1.013 into 10 to the power 5 divided by 1.67 into 10 to the power 8. So this Pascal will be getting cancelled. ATM to Pascal. Hey, you know this thing, right? 1 bar is equal to 1 ATM. Okay. So what is the value of 1 bar? 1 bar is equal to 0.9865 in your physics. படிச்சிருக்கீங்களா? வேல்யூ எங்க இருக்கு? See, 1 bar is equal to 0.986923 atmosphere. Or physics, there is an equation of this pressure is equal to thirst divided by its unit area. That is directly proportional to its thirst and inversely proportional to its unit area. So adula inda idella padichirpingalla. Mudiliya. Okay. Next one, ATM is equal to 1.01325 bar, and finally 1 ATM is equal to, from this only 1.101.325 bar into kilo Pascal. So அதை வந்து என்ன பண்ணுவாங்கன்னா into 10 to the power 3 போட்டு finally 1.013 into 10 to the power 3 Pascal. This is all your fixed values in the physics. Have you gone through these things? Well, so here என்ன பண்ணலாம்? The 10 to the power -3 மேல கொண்டு வந்துடலாம். So 2.5 into 1.013, which is 2.5325 divided by 1.67. So 2.5325 divided by 1.67 is equal to 1.51 into 10 to the power -3. Everybody got this answer? Clear? You have any doubt in this? Shall I repeat? No. You got it. Everyone got this thing. See, this is actually the most important thing in your conversions. So now, What they have been asking, calculate the quantity of carbon dioxide 500 milliliter of soda water which is packed at 2.5 atmosphere. So you need to calculate the number of moles of carbon dioxide. So that is nothing but given mass divided by molar. Huh? 5(2). Okay, 5(1). So now for this, we need to go for mole fraction of carbon dioxide is equal to number of moles of carbon dioxide divided by number of moles of carbon dioxide plus number of moles of water. Okay. So here number of moles of carbon dioxide divided by, they have given for your water, it is 500 milliliter. Okay. So 500 milliliter means divided by 2. So 55.5 divided by 2 is nothing but 27.75. And your mole fraction of CO2 is 1.51 into 10 to the power minus 3. Okay. So now multiply this thing. Number of moles of CO2 is equal to 1.51 into 10 to the power minus 3 into 27.75. So 1.51 into 27.75 is equal to 41.90 into 10 to the power minus 3. So now this is, they are asking quantity. Quantity is nothing but number of moles. Okay. So number of moles of carbon dioxide is equal to given mass divided by molar mass, which is given mass is 41. Given mass kudukala. Given mass than kekranga. Okay va? So given mass is equal to 41.90 into 10 to the power minus 3. Molar mass is carbon 12, oxygen 1 is 1632, 44 into 44. So which is 41.90 into 44. So given mass, that is your quantity of the substance is 1843.6. Can say it in grams. Got this one, everyone got this one. Huh? First of all, write these conversions, okay? Just write these conversions. Another problem. Are you trying another problem? Okay, wow. I'll not help you. Let's see who is just giving the answer, okay? Last, the final step of first step. In Raoult's law, there is 10 sums. In colligative properties, there is 12 sums. In azeotropy, there is sums. In ideal and non-ideal solution, there is sums. Huh? In electrochemistry, there is sums. In chemical kinetics, there is sums. Okay, just copy. I'll write the next question. Let's see who's doing. I have got many problems. But, oh no. This is in the problem, man. Don't worry about ducting and all. Okay. In laboratory wise, only these kinds of things they will be getting carried out. Okay. H2S gas is toxic. See, simple one. Okay. But lighter, like trick. There is a small trick is there. Let's see. With rotten egg, like smell is used for qualitative analysis. No, quantitative. That there only the concentration will be there. If solubility of H2S in water at standard temperature pressure is 0.195 molality, small m. Calculate Henry law constant. Let's see who is doing this and saying the answer. Molality. Capital M na molarity. Small m means molality. And the pressure, see, it's standard temperature pressure means we can take it as 1 atmosphere itself. No issues with that thing. Molality pressure they have given. So you can find the mole fractions. Let's see who is doing this thing. What is molality? Number of moles of your solute in 1 kilogram of your solvent. Correct? So inge vandittu number of moles of your solute is H2S. Very easiest one. Here வந்து 1 kg தான் இருக்கு. As such அப்படியே உங்களுக்கு வந்துட்டு என்ன தெரிஞ்சிருச்சு? Molality என்ன? Correct? Number of moles of H2S. This is molality. Okay. So from this molality you can find the number of moles of your solute. Molality. M-O-L-A-L-I-T-Y. Molality. So in the formula, the molality is equal to number of moles of solute divided by 1 kg of solid you will put now. And the molality in the right 0.195 is equal to, you don't know the number of moles of your solute. Solute is H2S. So here 1 kg. You will be taking your molality. That is here they have been given. Water. Okay, va? Always it is just taking 1 liter only. Okay. Clear na enna solren. The answer is like number of moles of H2S is like 0.195 da. அவ்வளவுதான் கீழ வந்து 1 தான இருக்கு. So அதனால நீங்க cross multiply பண்ணீங்கன்னா என்ன வரும்? அதே தான் வரும். Clear-ஆ? So number of moles of your number of moles of H2S is 195. The answer is 1 na. Why getting pissed off, huh? Answer is 1. Edu 5.02. Sure. Huh? Pressure 1 atmosphere, 1 bar in the comma. Don't count it in Pascal. 1 atmosphere or 1 bar, anything else. Here your solute is H2S divided by 1 kg solvent. Okay. So here it is 0.195. Okay, molality. That is your number of moles of H2S. Okay, so N H2S enna 0.195 Molality. Not molality. Okay. So now 100. Check it, man. Do it again. So next one is mole fraction of your H2S is equal to number of moles of H2S divided by number of moles of H2S and water. Okay. So here number of moles of H2S is 0.19 divided by 0.19 plus 55.5. See, there you just do, because they have given. That is what we have found. Number of moles of solute H2S. That's what I said. If they have given means you can incorporate it. If they're not given means it's negligible. So 0.19. This is what? Because that is what we have found here. Number of moles of H2S is grams. So this is what we have found here, right? Always in counting of now you got the thing. Now I'm saying if you're not putting also the same thing is coming. Huh? Then you can neglect if they are given means what is the thing procrastinating? Same answer is coming, but once they have step mark. $270. 285. I'm getting 285. I'm getting 285. What is this value? Mole fraction. Mole fraction of your solute. 0.195 divided 0.195 into 55.5. (0.195) plus 55.5. So 5.695 0.195 divided by 55.6. So which is equal to 0.0019. Okay, fine. 195. With 195 also similar value will be. So 3.5 into 10 to the power minus 3. And now next, what is the question they have been asking? Partial pressure is equal to KH into X. So partial pressure is 1. What is your KH? We need to find the KH. And your X is what we have derived here, 3.5 into 10 to the power minus 3. So KH is equal to 1 divided by 3.5 into 10 to the power minus 3. So which is nothing but 1 divided by 3.5. Now you got a 2.85 into 10 to the power minus 3.
Ma'am, can you scroll a little bit up?
Anyway. Plus 3. Sorry. Mala on this. Numerate. Sorry. How 10 to the power 2? See here 0.0035. So I'm just bringing here, right? And that is so here the problem arises. Okay. You having any doubt on this thing? No. Seriously? Calculations going big without calculator. You're not having mobile with you. Huh? You will do it. What about the rest of members? Okay. Yes. So we can stop till this. Already it's becoming 6 o'clock. I'm getting into the next one. Raoult's law. Now the application part. Abba, see, don't worry. Today at least you got 50% of understanding of clearing the problems. Okay. Next class, first half an hour, we can try another 5 Henry loss problems. Okay. So we'll be getting a better clarity. Clear? Don't worry. Because solution is a big chapter and more amount of problems you just need to solve. Then only you'll be getting a clarity. Clear? See, in Raoult's law, still more the problem will be hectic. Okay. And in qualitative properties, in abnormal pressure, just go. So just solve more number of problems. In your exercise or your in your book itself, there is more number of. I have solved most of the things. If there is any leftover, means go and solve them. Okay. There is if you have any difficulty, means approach me. I'll solve it. Okay. Yes. So next one is another one more thing is actually this Henry no. Ipo kadada. Okay. So just come back. Enough for all 5 problems you got answered. Go. No problem for you. Then go drink. Sorry, first. But like that, you will be not asking your exam. Seriously, you're getting? Hey, just 2 minutes, man. Andringa.
Ma'am.
Enough. No, let them breathe. Next class, I'll do the question, okay? I have many questions. If you want, just take a photocopy and go and solve it. Tomorrow is a halo against halo instance. Confirm. Okay. I don't know. See, alcohol, phenol, ether, you're just having in your memory. Once this man asked what is Williamson synthesis, no, my heart shattered into pieces. Okay, so now we can get to a next one. That is seen at keeping a constant temperature. Okay, this Henry law suggested the equation of partial pressure is equal to KH into X. Okay, so slightly he made a modification. What he made a modification in the sense, so he took the oxygen gas. Okay, so he is increasing the temperature first at the temperature 293 Kelvin. Okay, he calculated the partial pressure. He calculated the mole fraction. Finally, the Henry law constant for this oxygen gas at 293 Kelvin is 36.09 bars. Okay, so still what happened? Again, he is still increasing this temperature like 303 Kelvin. At that time, what happens? This Henry law constant value is like 40.08. So this is like approximately. So from this, he came to the conclusion on increasing the temperature, what happens? This Henry law constant is also getting increasing. Okay, so now at constant pressure, what's this thing? I'm keeping my pressure at constant value. So KH is equal to P by X. If my pressure is constant in the sense, as this Henry law constant is getting increasing, what happens to that? It is getting decreasing. Okay, which is nothing but once you can see if your temperature is increasing, what happens? Your Henry law constant is also increasing, which means your solubility is getting decreasing. Correct? Henry law constant only in terms of temperature. Okay. So if your temperature is increasing, your solubility is getting decreasing. Okay. So now I'm giving a general question. You know the aquatic organisms on the water left, there will be oxygen is present. Okay. So there will be change of seasons will be there. Okay. Whether their better survival will be having, like I'm saying, survival is there. Better survival occur when the better survival will be there in hot water or in cold water. Why? Why? Exactly. So if in hot water, what happens? The temperature increases means the solubility will be getting decreased. Why the solubility getting decreased? The gas particles will be easily getting evaporated, correct? So that is why that application, the aquatic organisms which is present in the water is breathing because of this law only, which means he has applicated, he has connected to this thing. That is the first application. Second one is your cool drinks. புரிஞ்சுதா என்ன சொன்ன aquatic organisms புரிஞ்சுதா? Second one is your cool drink thing. On that day itself, I expressed, correct? On high pressure, what is happening in the sense, we are just dissolving our carbon dioxide gas in liquid. So what happens? High pressure. Okay. So when you're just opening it and heating it means what happens? All the gas molecules will be easily getting escaped. Second one, you know about scuba diving? Scuba diving. So there is a cylinder you will be holding on your back. What is the cylinder consist of? Only oxygen is there. What is this mixture? If only oxygen is there means with only you're just carrying the oxygen when you're just deep diving into the sea. Okay, you're just going into the bottom of the sea. What happens? What will happen? If pressure is getting increased, here under the water, under the sea, there'll be more pressure. How there'll be more pressure? Above more water is there. More water is there means high pressure will be there. Due to gravity. Because of the gravity, what happened? All the gas molecules will come closer up. Main altitudes at high heights, what happens? Pressure. Why? Because all the gas molecules will be far away from each other. At deep diving at the lower bottom of the sea, there'll be more pressure. So you're just holding your oxygen cylinder. When you just deep diving means what happened? Your oxygen cylinder tank will be getting burst out. So not only oxygen gas is present inside the cylinder, nitrogen gas is also present inside the cylinder. Okay, so oxygen plus nitrogen gas is present. Why you're just why they are infusing the nitrogen gas into this oxygen gas? To stabilize. Okay, to stabilize this oxygen with nitrogen only, they are just infusing it. So once after, there is a thing called BEMS. What? I'm saying that thing. See, actually, we are just only breathing, inhaling carbon dioxide, exhaling oxygen. So once you're inhaling nitrogen means what happens? Oh, sorry. Inhaling oxygen. Sorry, my fault. My fault. I agree. Okay. Inhaling oxygen, exhaling carbon dioxide. If I'm inhaling nitrogen means what will happen? Exhale carbon dioxide. என்ன ஆகும்? So deep water la enna pandringa, you're inhaling your carbon dioxide. Oh god. Okay, inhaling your oxygen with the nitrogen gas. Nitrogen is a gas. It will be getting dissolved in your liquid. Gas in liquid, Henry law. So once you're just inhaling the nitrogen gas, it will be getting into our body. So what happened? It will be traveling into our body. Once you're just getting out of the water in the sense, let's suppose nitrogen gas traveling like this in the sense, once I'm getting out of the water in the sense, this nitrogen gas will escape from our skin and blisters will be seen on your skin. First one. And fever, fatigue, body pain, everything will be there because of the inhaling of nitrogen gas. Clear? That is known as BEMS. The people will be feeling very much tired after doing this deep sea diving because of the inhaling of the nitrogen gas. That is your Henry law. That is gas dissolved in liquid. Nitrogen gas dissolved in your blood. Clear with this one? Clear up? Then if you're keeping a separate jar means it should mix with oxygen. If nitrogen and oxygen are just in like both are in the same ratio means they will make a reaction. Okay. So if oxygen is only one present means all the pressure in the sea, no, what happened? It will tend to bring all the oxygen molecules together. At one point, what happened? More amount of pressure if you're just giving means what happened? The cylinder will be getting blasted. So if there is nitrogen present means this oxygen and nitrogen will try to make a reaction. Okay. So, இது வந்து before 10 years. Okay. Initially, the scuba diving வந்ததுக்கு அப்புறம் after that, people got a suffocating. So, after that, nowadays, what they are doing means they are mixing some inert gases like helium into it to avoid these bends, the fatigue. இதெல்லாம் நல்லா கேளுங்க. You just listen this everything into coming to problems means very dormant. That is the one thing. Next one is altitude sickness. Altitude sickness means what happens? Pressure is directly proportional to your mole fraction. Pressure is directly proportional to your X. Where if you are increasing the pressure means what happens? The solubility of gas is also increasing. If you're decreasing the pressure means the solubility of gas is also decreasing. Altitude scoring. Okay, va? Pressure down now. So the oxygen that you're inhaling means it will not that much easily solubilized in your blood. Correct? Bread. It will not easily getting solubilized in your blood. So what happens? Shortness of breath. Sometimes heart attack will happen and some people will die also. Okay. So what happens there? You will inhale oxygen, but it will not have that much amount of solubility because of the low pressure. This is also connects with Henry law. Clear with this one? These are all the applications that is connecting the Henry law in our day-to-day. Okay, va? Any other questions? No, right. Okay. Next one is coming to our not last. Vapor pressure. Okay. Now, as I already in the name of this thing. This is Henry law. Actually, he have done everything. He have set his definition everything. What happened? He is doing with certain number of gases. Like for oxygen, he carried out with oxygen. What happens? At increasing the temperature, he is noting that this Henry law constant is also getting increased. So once after carrying out this temperature, is carrying out with pressure. At that time only, he is just connecting with the applications. Clear? This is a general thing. Okay. So now coming to the vapor pressure. First one, before getting into the vapor pressure, as I said, this thing, right? See, you can see a droplets of water is present here. Similar thing, as he said, vapor pressure is nothing but this liquid will absorb the energy from the surrounding. Okay, fine. When I'm opening this bottle, okay, I'm keeping like this. Say, for example, the mouth is wide. Okay. After 1 week or 2 weeks, you can see this water will be getting decreased. The level will be getting decreased. Suppose if I'm closing it, the level is not decreasing. What is the reason? Not evaporating. Yes, you're almost right. Be much more precise. Evaporate or gas will come into liquid. Okay, you're almost right. Another Raoult's law. Shall I explain it? So what happens in the sense you're fixing a boundary. So what happens? This liquid, of course, what happens now? Okay, all the molecules will be getting up as a vapor and it will hit the boundary and again, all you know about free surface. What is free surface? You can say that what is a free surface? What is a free surface in solid? What is a free surface in liquid? What is a free surface in gas? What is free surface? So evaporation is a surface phenomenon or bulk phenomenon. How do you say it's surface? More the surface area, easy the evaporation. The particles will be more, like much more. It will be kinetic energy will be more. Okay. So similar wise, in this the top layer, what happens if this is your chamber means here your water molecules present in this way. See this. Surface molecules only will be getting evaporated. Here also the process will be taken, but the kinetic energy more in this surface, correct? So once what happens, if it is escaping as a vapor, it will go, it is a confined boundary, again it will come back. Okay, at one point what happens, equilibrium takes place. Equilibrium takes place in the sense, the amount of liquid that will be converted into vapor, and again the vapor will be getting converted into liquid. So that's why your liquid is remaining constant here. Okay, so what happens here in this sense? I have another example. So this is one thing. Now this is vapor pressure. Going, it's just going, hitting and coming. This is vapor pressure. Now I am doing another one more thing. You want a definition for vapor pressure? It is there in your system. The pressure created by the particles of the vapor. The pressure created by the particles of the vapor on its own liquid surface. The pressure created by the particles of vapor on its own liquid surface. So this is a liquid. This is acting as a vapor on its surface. I said no, evaporation is the surface. On its surface only everything is getting happen. Clear with this one? Now, this is only possible for volatile liquids. Clear? Like acetone, water, petrol, kerosene, alcohol. These kinds of volatile liquids only it is possible. For non-volatile liquids, it is not at all possible. Like oil, or if you are taking any solid substance like NaCl, it is not possible. Now, we can come to Raoult's law foundation. That is how he said the thing. See, I'm taking 3 chambers. Listen carefully. If you got this point, means it is easy for you to crack the problems. Oh, why it is? What is not possible? Huh? Oh. See, yeah, why it is not possible means the density is small. The intermolecular space is quite tightly packed, so it won't easily release the particles. Correct? What is not possible now? See, what is not possible means? Yeah, I know, man. I am just getting interested. What is not possible means? Hey, that's what. When what is not possible, what is the question? No, it should make sense. Why? That is what I'm saying now. Why it is not evaporating? Because of the intermolecular. I think it will take 2 months for us to complete the solution chapter. Seriously. What is not possible? Okay. See, 3 chambers is placed in front of you. The first one, see, this is nothing but your surface molecules. Okay. So this chamber, here, there is some liquid is present here. Okay, wow. So we can name this chamber as A. And there is only solute is present in this chamber. Pure solute is present in this chamber. So if pure solute is present in this chamber means we can name it as P0A. Okay, wow. Now we are going to write the equation. P0A means only solute is present. No solvent, no solution. Only solute is present. Now, in the second chamber, only solvent is present. Only pure solvent is present. P0B. Okay. So in the first chamber, what will be getting happen? The liquid is there. So definitely this liquid will absorb the energy from the surrounding and it will be converting into vapor phase. So what happens here? All your vapors will be present here. Okay. So here also, in your solvent also, all the vapors will be present. Now answer the question. Here, this vapor, liquid will easily getting converted into vapor and this vapor will create a pressure. Okay. So this pressure, when it is in a separate chamber as only solute, this vapor pressure will be high or low. Separate, just only solute is there. So how this vapor pressure, whether like the vapor pressure will be more or the vapor pressure will be less. See, compared to what means as a solution is there. So solution consists of solute, solvent, everything. Here only solute is present, only solvent is present. Okay, wait, I'll explain this thing. In chamber C, I'm intermixing both solute and solvent. In the chamber A and B, I'm mixing both things. So we can't say this is pure. This is a solution, correct? So here what happens again, see, this is a solute and this is a solvent. So both will be getting intermixed. So what happens here like this, all the solvent and solute particles will intermix. Of course, here also what happens, the gas will be just coming out in a vapor. Clear? Now my question is, all the 3 chambers exhibits vapor pressure. You can agree? Because everywhere the liquid is getting converted into your gas, and every one of the chambers small and it will exert. Here there is only solute. Here there is only solvent. But here it is a combination of both solute and solvent. My question is, vapor pressure of your solute and the vapor pressure of solvent is separate. And the vapor pressure of solute, which one will be having more vapor? Solution. Justify. Okay, vapor pressure எதை depend பண்ணிருக்கும்? How like how you know if how can I say? If there is like you know depends upon no almost no it's not density. Wait. See, if there is more surface there, let me say openly. If there is more surface area there, less surface area there, where the vapor pressure will be more surface area. So for the solute here, more surface area is there or less surface area? More surface area. Here it is present as a solution. Okay, now so solute combined with your solvent. So here the surface area will be less. Partial pressure of, I'm asking for solute, separate solute, separate solvent. Then intermixing. See here there is no word partial because intermixing is not taking place. No. Here I am not comparing. Comparing this is separately we will be dealing with. I'm comparing this one. Clear? So which one will be having more vapor pressure? Solute and solvent, which is present in the separate chambers, will be having more vapor pressure. What about this one? It will be having less vapor pressure. Why it is having less vapor pressure? Because less surface area is present. Once you are intermixing your solute and solvent, as it what happens, this will be occupying more surface. Correct? So what happens? The surface area will be less and its vapor pressure will be getting reduced. So this is known as lowering of vapor pressure. That is a topic in your NCERT textbook. Lowering of vapor pressure in the sense when you are mixing with your solute and solvent, at that time your liquid will be getting evaporated into vapor and it will create some pressure, but that pressure will be comparatively less when you compare to separate solute and separate solvent placed in the chamber. Clear? In the booklet there will be perfect explanation for that. Perfect definition will be there. You can go through it. 1 minute. And the 15 minutes. Okay. So next one is this is the first one. Lowering of vapor pressure. So now just see this one. What is lowering of vapor pressure? Now Raoult's law says this pressure applied by the solute or solvent in a solution, correct? The pressure will be creating here. As well as again it will comes back and again in the solution also it will create a pressure. Can you understand it? See, it will go and create the pressure here. It will go and hit. Again, it will come and again here also what happens? It will give the pressure via hitting. So that's why the equilibrium takes place and the solution is remaining constant here. Correct. So what happens here? The pressure applied by the solute or solvent in a solution will be directly proportional to its mole fraction. The pressure applied by solute or solvent in a solution is directly proportional to its mole fraction, which is P is directly proportional to X, which says the Henry law. Henry law concept. Pressure. See, what happens in the sense? The vapor doesn't go immediately. What happens? It heat and again it comes right. So what happens? Solubility is there, right? So that is what I'm saying. The Pressure created by the solute and solvent in the solution is directly proportional to its mole fraction. So now we will be having a doubt. Again, if I'm saying this will be equal to your Henry law, correct? But this is Raoult's law. What is the difference in the sense? Your Henry law will deal with only gases, but your Raoult's law will be dealing with these kinds of volatile liquids. Purely, it will deal with only liquids. Clear up? Clear with this one now? The next column, okay. Easily getting evaporated. Okay, wow. Yes. If one of the thing is non-volatile also, this will not happen. Clear? Okay, wow. Henry law deals with only. வீட்டுக்கு போறாங்க போகட்டும் அங்க பார்த்து என்ன நம்ம பண்ண போறோம் நம்மளுக்கு இன்னும் 15 நிமிஷம் இருக்கு சரியா ஓகே ஃபைன் இப்போ என்ன வாட் ஐ செட் what I said pressure is directly proportional to mole fraction. The pressure applied by the solute and solvent in the solution, okay wow, both solute and solvent, both of them is liquid here, none of them is gases. Can you identify the small difference? That is matters in the solution chapter. If you can't understand means definitely you can't hit it. Okay, so here this Raoult's law speaks only with the volatile liquids. Both your solute as well as solvent, both of them should be volatile. Now we can write the equation. Okay, so first one is if I'm taking the solute. If your solute is PA, so this PA is nothing but chamber la, when I'm dropping it as a pure solute, I have mentioned it as P0A. Do you remember that thing? What is P0A? It's pure solute. P0A, pure solvent. So here, PA in the sense, what is PA? Solution, right? So here, in this chamber, in this P0A and P0A, the pressure will be there as a vapor pressure. But here, the vapor pressure is present as a partial vapor pressure because we're just intermixing the PA and P. Correct? Partial vapor pressure will be there according to Dalton's law. Correct? Intermixing of that. So now we can write this PA is equal to P0A into FC. Clear with this one? How I connected this place? Can you say? Total pressure. See, this PA is nothing but partial pressure of your A na solute vechikalam. Okay va? Partial pressure of your solute in solution, which is equal to vapor pressure of your pure solute into its mole fraction. Here, can you understand? When the liquid is just getting evaporated, okay, again it's just hitting the surface and again it's getting solubilized. When I'm just speaking about in the total chamber. Total chamber la na solute mathra edukren. I'm taking only the solute. Clear? Now I'm taking the solvent. Similarly, see, I can easily write this derivation and I can go. I'm trying to explain. Just try to understand. Now I'm taking PB. PB is present in this chamber. Clear? This chamber, you have both your solute and solvent. In your textbook, they won't give solute and solvent. They will be giving component A and component B. Don't get confused. Component A means your solute. Component B is your solvent. Okay? Yes. So PB is equal to P0B into mole fraction. Clear? So this is nothing but partial vapor pressure of the solvent in the solution. Clear? This is nothing but vapor pressure of your pure solvent and its mole fraction. Clear? This is what happening in the chamber when you need to see your PA. Now, what is the total vapor pressure of the chamber? Correct. P total is equal to PA plus PB. This is your sum. And now you can write this thing as P total is equal to P0A XA plus P0B XB. Clear with this one? Yes. So now we can draw a graph. Just constant. Carefully listen this graph. This is your graph. Yeah. So, this is graph. I will explain, man. Wait, man. This is your vapor pressure. Here also your vapor pressure. And here we can take your mole fraction. Okay. First one. So here XA is nothing but your solvent. That is mole fraction of your solute, which is 1. And XB is mole fraction of your solvent, which is 0. Okay. Google next time I'll bring it. Okay. So now, see, listen here. If your solvent is 0 in the sense, okay, if your solvent is 0 in the sense, there is only your solute is present in it. Okay. So this is happening in this way. And look at here. So if I'm trying to increase here, X is equal. Here at this point, what happens? Your XA will be 0 and your XB will be 1. I'll explain this thing finally. Now you will not get understood. Hmm. 0.8, 0.2, 0.6, 0.2, 0.4, 0.0. Okay. So these are all your mole fraction values. Okay. So first one. Here and here. Okay. Here and here. In both the ends, there is no solution present. Okay. Here there is only pure solute is present, and here pure solvent is present. So just leave these two things. And in between 1, 2, 3, 4, all your 5 values, there is a solution is present because it is a mixing of both your solute and solvent. So from this end to this end, okay, the solution is present, and here there is only your solvent is present. Okay, sorry, here your solute is present, here your solvent is present. So if your solute is only there means, so here it's vapor pressure, you can mark it as PA. Clear up? So here your solvent is present means mark it as PB. It's vapor pressure. Okay. So take a look at PA. PA வந்து என்ன range ல போகுது? 1, 0.8, 0.6, 0.4. It is increasing or decreasing? Decreasing. So this PA curve will be in a decreasing way. Clear up? Now take a look at your PB. 0, 0.2, 0.4, 0.6, 0.8. It's getting increasing up. So what happens? This curve will be showing an increasing trend. Clear with this one? So where your P total you can calculate. Exactly. So in this PA and PB, your P total can be get calculated. That is PA and PB. Clear up? So now if I want, see, if you know about your mole fraction values of your solute and solvent. Okay, from this graph, say for example, if my mole fraction value of solute is 0.4 and 0.6 means you can plot easily from here. So at this point, here your PA, and this point, here your PB, and here you can find your P total. P total? How it will be remaining constant? How you are saying it's constant? No, it's not straight line. It will be like this. Oh, it's slant area. It will be little bit in a slope way, in this way. Okay, I'll show you the image. In your book, the graphical representation is there, right? Take a look at your book. It is quite slanting in this way. Not that much. It's ரொம்ப slanting ஆயிருக்கா? It will be quite in a slanted way like this. In your Singh's publications, there is a minute difference. So it will be in this way, and from this graph, you can find for 2 volatile liquids. Your solute is also volatile. Your solvent is also volatile. Means you can take this graph and you can calculate the values. Sounds like one more. Graphical representations, it will be in this way. Clear with this graph? And clear with curves, everything you got clear out. Okay. Here it is present only as a solvent. Here it is present only as a solute. The solution is there. Now to know each and everything is clear out. Now, in worst cases, say for example, the worst case is like one of your solute is non-volatile, your solvent is volatile. At that time, what happens? Exactly. See, if I'm taking here, is there any example I have taken? Said okay, fine. If your total solution in the solution PA plus PB. Okay, if your solute is your non-volatile substance, now 0. So just your PB will be remained there. So P solution, total solution is equal to only PB, which is nothing but PB is P naught B into XB, likewise. And if you want to draw the graph means, similar graph, everything will be there. XA is equal to 1, XB is equal to 0, XA is equal to 1, X0, XB is equal to 1. So what happened? Only one of your curve will be there. Another curve will not be there. Why? Because another one is a non-volatile liquid. Okay, the solutions will go, but it will not be, the vapor will not be getting out of the liquid. So what happens? The vapor pressure curve will not be there. Say for example, if there is only solute means it will be showing only this graph. And your solvent is non-volatile means there is no graph will be present. Okay, clear with this one? Huh? Solute volatile. Huh? See, wait. My solute is volatile. Solvent is non-volatile. You can take in any way, man. Okay, which one is non-volatile? What happened? The liquid will not escape as a vapor. So the graph will not be there. Which one is volatile? The graph will be there. Clear with this one? Okay, wow. Now next one. No. In solution, see, you're mixing. Of course, you are mixing your oil with water. Of course, it will be getting insoluble. But your heating is, which one will be getting vaporized? Your water will be getting vaporized. Your oil will be remaining, right? So the vaporizing one, that is vapor pressure. Here we have not the vapor pressure. P total will know how you will calculate the P total. There is only one component. So for this, that is for the solution. See, look it here. Huh? Clear? That's it. That is what I have written here. You have to keep it as 0. Okay. Yes. So have any doubt here? Solunga. Time acha. Enakku puriyudhu. Time acha. Or problem solve pandringla. Problem solve pandringla. One small concept is there. See, still now you have seen like 80%. Remaining 20% says this is a chamber. Okay. So far, all these calculations we have done in this solution. How the solute and the solvent is present mole wise. Now, my question is, the vapors are okay. How this solute and solvent is present vapor wise? I want to know how this solute and solvent is present vapor wise. Can you understand? Can you understand? To what to know what? What we are going to do from this? What is a property around law? You are saying in application oriented form. Hey, what man? Vidingada enna naanga oruthar mudiyala. Then here we are finding in the solution. We are finding for this in the vapor phase how to solve it. The solution in the vapor phase how to solute and solvent exerts pressure. what I'm asking you. How it will be excess pressure here. Here in solution. Can you understand my question? In solution, it's just getting solid-based. Okay, so what we are just doing, we are taking solute in mole-wise, solvent in mole-wise, and we have written all these types of things. Now, I want to know, please forget the solution. This surface is not there. Here, in this vapor phase, there will be solute and solvent, right? Okay, so I want to know what is the vapor pressure exerted by the solute and solvent in this vapor phase. Okay, so there is a formula for that. Clear up? Huh? But the variables will be quite different. Okay, I'll be writing that thing also. And next class we can do the problems. Okay, so it is P in the unga book la variables la vera mari irukku. Variable, see, PA na P1 irukku. PB means P2. That's it. Okay, solute will be like component A, solvent will be component B. That's it. Okay, no vast difference and all there. So your PA will be directly proportional to your YA. So here, what is this YA? What is this PA? PA is similar. Last one that is present in the solution. So this is nothing but mole fraction of your solute that is present as a vapor. Clear? What you got? I'll write this thing. Partial. No. I'll say this thing. Wait. Partial vapor pressure of the solute in solution. This is mole fraction. Actually, anga XN potadala, I'm changing it by Y here. Okay. Don't think Einstein's equation has changed. Okay. So mole fraction of solute exerts its vapor pressure in vapor phase. Exerts its pressure in vapor phase like this. Okay. So now this is a difference. Purida, angi difference purida. Now I'm incorporating another one more thing. So this equation can be written as PA is equal to YA. PA is equal to P total into YA. PA is equal to P total into YB. Avlodhaan. Idoda mudinjadhu. Why I have written total. This answer solunga and you be. That's it. Solute and solvent means I have written one thing. Avlodhaan. Idoda mudinjadhu. These are all the formulas. Wait, hey, answer solunga. In a bag edukreenga. Okay. He is right. Purinjudha enna sonnarla? Enna sonnaru? What he said? Okay. Go. Next class, I'll just explain and I'll do the problems. Next class, like first half an hour, entries law problems It's the first, yesterday, no. 10 to 15 minutes, I'll be not here. So next Thursday, are you doing the problems? Tomorrow, 5 to 6. You can just confirm with the basket. Thank you. Guys, pull it up. Thank you. Okay.